Hello everyone, welcome to my new lecture series. Myself T.Vignesh, working as an assistant professor in Department of Mechanical and Mechatronics Engineering in SNS College of Engineering. So in this lecture series we are going to talk about one of the application of heat and mass transfer, that is heat exchangers. Okay, so heat exchangers are indispensable devices that transfer thermal energy between the fluids or solids at different temperatures. So in general, if you go for the heat transfer, it takes place at higher temperature region to lower temperature region, and this heat exchanger is a device which helps these heat transfer mechanisms at a faster rate. So these devices are crucial in processes ranging from large-scale industrial operations to home appliances. So their efficiency directly influences energy consumption and costs. And so if you go for the basic principle, the core principle involves transferring heat from hotter fluid to a cooler one until both approach a thermal equilibrium. So you know what is meant by thermal equilibrium, right? So thermal equilibrium, like if you have uh, a water at two different classes and both are at in different temperatures, one is at 35 degrees centigrade and another one is 15 degrees centigrade, and if you mix both, what will happen? The temperature tries to uh, get into somewhere at a constant rate, right? So this is called a thermal equilibrium. Okay, so both the hot water and cold water tries to be at equilibrium state or equal temperature, try to be at a equal temperature, so that is called thermal equilibrium. So this heat exchanger device is also works on the same principle. See, it has a array of tubes. In general, heat exchangers, it has an array of tubes where in one tube, what will happen, the hotter fluid gets passed, and another tube, what will happen, the fluid gets passed. So typically in these two tubes, two different fluids at two different temperatures are passing, means what will happen, the colder fluid gets the heat from the high temperature fluid. Okay, so this is the basic principle involves in the heat exchanger. So temperature difference, flow rate, heat transfer coefficient and surface area are critical parameters for the heat exchangers to work on. So metrics include the overall heat transfer coefficient, effectiveness and pressure drop. This also plays a major role. And in order to uh, manufacture the heat exchangers, we need typical materials include stainless steel, copper, aluminum, and titanium, each chosen for their specific thermal and chemical properties. So there are different types of heat exchangers are there. Most commonly shell and tube, plate heat exchangers, air cooled heat exchanger. So cell and tube is a common type. Okay, so known for their suitable for higher pressure and temperature. They're frequently used in oil refineries and power plants and account for 40% of the market. And plate heat exchanger, it is very compact in nature and highly efficient, and this can be used in the HVAC systems and in food processing units. So application, if you go for the power generation, cooling steam and preheating boiler feed water enhance cycle efficiency and reduce emissions. So coal plants can recover up to 30% of waste heat. And in HVAC systems, so heating and cooling buildings and recovering waste heat improves energy efficiency and reduces the cost with potential savings of up to 40% in energy consumption. So these are all the applications of heat exchangers typically in the across the industries. So the importance is heat exchangers are very essential for thermal management and energy conservation across industries. Selection of heat exchanger depends on the fluid properties, temperature ranges, and pressure constraints. Because see, if you go for like uh, application oriented things where the heat transfer should be aqueous and heat transfer plays a major role, so in that, heat exchanger are the crucial one. It helps the heat transfer mechanisms at a faster rate. So continual advancements in materials and design boost performance and sustainability. Proper maintenance is crucial for long term reliability and efficiency. Even though, see, in heat exchangers we are continuously supplying the fluids, we need a proper maintenance, removing dust particles. So these are all the things which we need to uh, do in order to keep the efficiency going. So future trends include additive manufacturing for complex geometries, smart sensors for real-time monitoring, and high performance nanofluids, which will be implemented in heat exchangers for in order to increase its efficiency. So that's it for today. Thank you for watching.